Namaste, and once again welcome back to another session of online maths class. Last class we have learnt Rolle's theorem and we have discussed some problems in exercise 5.8. In this session we are going to discuss Lagrange's mean value theorem. Let's start. Lagrange's mean value theorem or the mean value theorem states that let f from closed interval ab to r, f from closed interval ab to r be a function which is continuous on closed interval ab, continuous on closed interval ab, and the same function is differentiable on open interval ab. If these two conditions are satisfied, then there exists some c in open interval ab such that f dash of c is equal to f of b minus f of a divided by b minus a. Okay, I repeat, let f from closed interval ab to r be continuous on closed interval ab and differentiable on open interval ab, then there exists some c in open interval ab such that f dash of c is equal to f of b minus f of a divided by b minus a. This is what is called Lagrange's mean value theorem, or simply we can say mean value theorem. Understood? Now we move on to the geometrical interpretation of this theorem. Okay. Consider this graph. Okay. So here I take this value as a and this one as b. Clear? So here we consider a function f of x, y is equal to f of x within the interval, closed interval ab. Okay. Now consider the first point, continuous on closed interval ab. That means the function should be continuous in the entire interval. Okay, look at the graph. Here we draw the graph without any breaks. Clear? We can draw the graph without lifting the pen from the paper, and we can say the function is continuous on the entire interval. That means the function is continuous on closed interval a comma b. Understood? Now the second one is differentiable on open interval ab. Differentiable on open interval ab. Differentiable means here we can draw tangents to the curve at any point except the extreme points. These two extreme points, that means the points a and b. So except at the extreme points we can draw tangents to the given curve. Okay. That means we can find slope of the tangent at each and every point except the extreme points. So slope of the tangent means what? Derivative at that particular point. That means dy by dx. That means the function is differentiable on open interval ab. The function is differentiable on open interval ab. Now these two conditions are satisfied. Then according to mean value theorem, there exists some real number c belongs to open interval a comma b. That means on real number c will exist between the interval a comma b, between a comma b, such that f dash of c is equal to f of b minus f of a divided by b minus a. Clear? That means I take the point as a, here it is b. What is the image of a under the function f? It will be f of a. So this coordinate can be written as a comma f of a. Understood? And here small b comma the image is f of b. So the point will be b comma f of b. Now we can join a and b to get a chord. So here AB is the chord to the curve. Okay. And we know the slope of AB as slope of line joining 2 points. We have formula y2 minus y1 divided by x2 minus x1. Slope of line joining 2 points x1 y1 and x2 y2 is given by y2 minus y1 divided by x2 minus x1. Okay. So which is equal to, here instead of y2 the value is f of b. So f of b minus and y1 value is f of a divided by x2 minus x1. Here x2 is b and x1 is a, that is b minus a. Slope of AB is equal to f of b minus f of a divided by b minus a. Clear? Now we can consider one point C. Here I take one point C. This is C and it will be f of c. And this particular point, if I draw tangent to the curve, definitely it will be parallel to AB. These two lines are parallel. The tangent I drawn here and the line AB are parallel to each other. Parallel means slopes are equal. Here the point is f of c, so slope means f dash of c. Okay, so f dash of c will be equal to slope of AB. So we can write it as f dash of c. Understood? So f dash of c is equal to f of b minus f of a divided by b minus a. That is the geometrical interpretation of this theorem. I repeat, Lagrange's mean value theorem states that let f from closed interval AB to R be continuous on closed interval AB. That means we can draw the curve without any breaks. Okay, without lifting the pen from the paper. If we can draw a curve, continuous curve, then the function is said to be continuous. And the second one is differentiable on open interval AB. Differentiable in the geometrical sense, we can find slope of the tangent at each and every point. So in this graph, we can draw tangents except the extreme points. Okay, and we can find the slope of these tangents at every point except the extreme points. So the function should be differentiable on open interval AB. If these two conditions are fulfilled, then there exists some real number c belongs to open interval AB such that f dash of c is equal to f of b minus f of a divided by b minus a. That means here we join AB, we get the coordinate as a comma f of a and b comma f of b, and if we find the slope of AB, it becomes f of b minus f of a divided by b minus a. And between these two numbers a and b, we can find a real number c such that the tangent to the curve is parallel to the chord joining a and b. Okay, that means the slope of these two lines are equal. Okay, two lines are parallel means slopes are equal. So here the point is f of c and slope of the tangent at that particular point is what? Derivative at that point. That means here a point is f of c, so the derivative is f dash of c. It will be equal to the slope of AB, and slope of AB we find it as f of b minus f of a divided by b minus a. That means f dash of c is equal to f of b minus f of a divided by b minus a. Clear? Now have a look at this example. Verify MVT, that means mean value theorem, for the function f of x is equal to x square in the interval closed interval 2 comma 4. So we have to verify the applicability of mean value theorem in the given function. Okay, first of all, the point is continuous, the function should be continuous on closed interval AB, and second is what? Differentiable on open interval AB. If these two conditions are fulfilled, then there exists some C belongs to open interval AB such that f dash of C is equal to what? F of B minus f of A divided by B minus A. Okay, that we have to check here. So given f of x is equal to x square, since f of x is a polynomial, it should be continuous everywhere. Okay, we know the continuous functions are polynomial functions, trigonometric functions, exponential function, logarithmic function, inverse trigonometric function. Okay, these constant functions, these all functions are continuous in their respective domains. Since it is a polynomial, it is continuous on closed interval 2, 4. So first we can write it. Since f of x is a polynomial, f is continuous on closed interval 2, 4. Now we can check the differentiability of the function. Here f dash of x, the derivative will be equal to 2x. That means the derivative exists. So we can say f is differentiable on open interval 2, 4. Now we can find f of a and f of b. Here f of a means f of 2, which is equal to 2 square, that is 4, and f of b, f of 4, which is equal to 4 square, which is equal to what? 16. Okay, if it is continuous and differentiable, then according to mean value theorem, there exists some C belongs to AB such that what? F dash of C is equal to f of b minus f of a divided by b minus a. So we can apply that. Here f dash of C is equal to f of b minus f of a divided by what? B minus a. Now we can replace the values. F dash of C, f dash of x is 2x, so f dash of C will be 2c. So 2c is equal to f of b minus f of a, that we already find it out. 16 minus 4 divided by b minus a, that is 4 minus 2. Okay. So 2c is equal to 16 minus 4 is 12, 12 by 2. 2c is equal to 6, or c is equal to 6 by 2, which is equal to 3. Now we have to check whether this number belongs to open interval 2, 4. Clearly 3 belongs to open interval 2, 4, and hence mean value theorem is verified. Okay, and we can conclude mean value theorem is applicable for this given function, and hence mean value theorem is verified. I repeat, first of all we have to check the continuity and differentiability of the function. Here it is a polynomial function, so we can write directly, since it is a polynomial, it is continuous on closed interval 2, 4, and check the differentiability. That is, here f dash of x is 2x, that means the derivative exists in the particular interval. So we can write f is differentiable on open interval 2, 4. That means the first two conditions are satisfied. So we go for the third part. That means there exists some C belongs to AB such that f dash of C equal to f of b minus f of a divided by b minus a. For that, first we find f of a and f of b. F of a is equal to 4 and f of b is equal to 16, and we replace in the formula f dash of C equal to f of b minus f of a divided by b minus a. F dash of x is 2x, so instead of x we can write c. So 2c is equal to 16 minus 4 divided by 4 minus 2, that is 2c is equal to 12 by 2, and 2c is equal to 6, which implies c is equal to 3, and we check whether the number c belongs to open interval 2, 4. Clearly 3 is a number which lies between 2 and 4, so we can write 3 belongs to open interval 2, 4. Hence we can conclude Lagrange's mean value theorem is verified. Understood? So this is about Lagrange's mean value theorem. In the next video we will discuss exercise 5.8 of Ncert class 12 maths. So keep watching. Thank you.